Alright, here I'm going to take a look at simplifying radicals. So in this example, I have the square root of 18 times x to the fourth times y to the third. The first thing to remember is that anytime I have a radical and there's no index written, that it's automatically assumed to be a 2, because this is a square root. And then anytime I want to simplify a radical, I want to ask myself first about the number. So I have the number 18. Are there any perfect squares that factor into 18? Now hopefully you can recognize that 18 can be factored into 9 times 2. 9 is a perfect square. So once I factor 18 into 9 times 2 and I see that 9 is a perfect square, I can use my radical properties to kind of separate this problem. Anytime I take the square root of multiple things that are being multiplied, I can break them each into their own radicals. So for instance, I can rewrite this as the square root of 9 times 2 times the square root of x to the fourth times the square root of y to the third. Okay? Well, if I look at this first grouping, notice that if I take the square root of 9, I'll get 3. But if I take the square root of 2, that can't be simplified, so the 2 will stay underneath the radical. Then if I look at the square root of x to the fourth, remember that the index is 2. 2 goes into the 4 twice, so I will get x squared out. There'll be none remaining, so I don't have the radical. And then lastly, if I look at the y, once again the index is still 2. 2 goes into 3 one time, so I get a y that comes out. But then I'll also have 1 remaining underneath the radical, so I need the radical y as well. Now, the last thing to note here is that normally when we simplify radicals, we want real solutions. So if I look at this, if I were to plug a negative y in right now, a negative to the third power remains negative, and then if I were to try and take a square root of that negative, I would get an imaginary number. I wouldn't get a real number. So anytime I have an even index, okay, whether this is a 2, 4, 6, any even number as an index, and I get an odd power out, right now this has a power of 1 on it. If I get an even index and I get an odd power out, I need to remember to put absolute values around what came out. So this should be the absolute value of y. Now at this stage in the game, all I have to do is kind of re-put things under the radicals, recombine things. So the 3 is on the outside, so I'm going to leave it on the outside. The x squared's on the outside, so I get 3x squared. And then I also have this absolute value of y on the outside. And then I just need to combine the things left under the radicals, so the square root of 2 times the square root of y will become the square root of 2y. This will be the simplified form of this example.